Thank you for joining us. Today we'll be discussing the common rail fuel system and some of the service challenges based upon the system and really the lack of information that's available out there as far as service shops and what they can do, things of that nature. But we're going to start with the common rail high pressure pump, the CP3 pump. And the CP3 pump, which typical application, Mitsubishi Fuso, Dodge Cummins applications, Cummins ISBE, ISDE. There's a myriad of them. General Motors Duramax, some of your agricultural equipment has this type pump on them. Typically, this is from model years 2001 to, the Dodge Cummins still has this same type system on it. It's a 3-element pump that has 3 pumping plungers, 120 degrees opposed from each other, represented behind these caps in this fitting. And this is the fuel inlet. This is the fuel return from the pump. Typically, these pumps are very durable. This is forged and heat-treated steel. The bores for the plungers are integral to the pump body. All these materials are very hard, very durable, but as with anything, you start introducing dirt and debris and water into them, they will degrade rather quickly. The pump is a very durable design, can go for hundreds of thousands of miles. Typically, anytime anyone has a problem with a common rail system, the first thing they want to do is put a pump on, which is a mistake. Because generally the pump will be the last thing to go wrong. Well, they can fail, but typically the injectors are going to fail before the pump is going to fail. Some features about the pump: it is a variable displacement pump, which means it only supplies the volume that the ECM is requesting based upon the signal it receives from the rail pressure sensor. And this valve is actuated. This is a volume control valve, a fuel control actuator, a fuel pressure regulator. Bosch calls it an improp. It's the inlet regulator, inlet control valve, whatever term you want to use there, that controls the output from this pump based upon requested rail pressure. So some issues, and people always think if you've got a system that can't build adequate pressure, well, it's got to be the problem of the pump. And sure, you can put bigger pumps, dual pumps on, and you can overcome some issues sometimes, but you, in the end up complicating the issue because, it usually turns out to be an injector-related issue, which is, reflected in the fact that the pump cannot build sufficient pressure. So the next thing we're going to talk about is the actual fuel injectors themselves, and also keep in mind the return on this pump as well. Right, this is a Duramax. This represents everything from LLY up to the last solenoid type injector on the LMMs they produce. This is your fuel inlet. This is your return. This return has a plastic fitting with a hose and a metal retainer ring that plumbs them all together. This is a Duramax LB7, same principle, inlet, return with a banjo type arrangement with a manifold type tube with a bolt in it. That's a hollow type banjo bolt. LB7s are really terrible to get rust in the system. A lot of times you find the lines are full of rust and it ends up in the inlet, goes through the injector and just eats them up. The inlets have what's called an edge filter, edge filter in them that, some people call them a chip grinder, because whatever debris is in there, the high pressure pushes the debris through the edge filter and gets it to a size that can be run through the injector. Not a good situation, but that's the way they're designed. No better way to do it, I suppose. Then we come to the Cummins arrangement. And there's others other than Cummins that have this arrangement. It's typical of 5.9 and 6.7. This is a 5.9 Cummins injector. The inlet has an inlet connector, or connector tube, high pressure connector. Your line connects here with a 60-degree cone The other end is a radius, semicircle, half of a hemispherical type shape. And it makes the connection here. So sometimes when you've got an issue, someone thinks it's related to the pump, and obviously the pump can't generate enough pressure, so it gets blamed, but you can have a leak here. You can have erosion, due to a tiny leak over time. It'll actually eat this material away, erode it away, or it'll erode away both the end of the tube and the seat of the injector. So then the pump can't build sufficient pressure to start the engine. That's one scenario. So another scenario is just general wear in the internal injector components themselves. This is a control valve for the injector. And in the top, I'm not sure how well you can see this, in the top there's a seat which is shaped like a cone with a passage in it. And the passage goes down through the top of the valve, so it can put pressure on top of this control rod and push it back down. Or it can actually vent the pressure. The way this is arranged in the injector body, there's a passage here that's always exposed to pressure. This is the control with a ball in it, and it essentially looks like this through the passage. And there's essentially a ball that sets in this cone shape and seals off this upper passage. So when it's in that configuration, the rod is pushed down hydraulically, and as the solenoid's energized, it raises an armature which allows movement of this ball, and the pressure is now diverted. It goes through the passage in the side up through the top of the injector control valve. And when it does that, this rod is pushed up by the pintle in this injector, and we'll show you this because it's exposed to the pressure as well through this passage here. So when we have fuel pressure coming here, it pushes this thing upward, which when it's lifted pushes this control rod up and allows fuel to flow out the orifices of the nozzle. So this passage has constant pressure available to it, and in the side of the control valve head, it also has a constant supply of pressure as well. So what can happen, this fit over time can wear in the nozzle. This is a new one, so it's good and tight. But the fuel that goes in between this fit, it's a mechanical seal based upon the clearance here. Whatever amount of diesel fuel is allowed to pass by here just goes out the return in the back side of the injector. Like I said, there's 6 of these through the cylinder head, and there's a passage that's drilled through the head, and there's a return line on the end, and all these intersect each other. So all your return gathers at one point on the Cummins applications, integral to the head. So not necessarily just wear here. You can also have cracks. You can have a crack here, and it'll get sent back up through the return. Could possibly go into the combustion chamber as well. We've seen nozzles crack on the side. That goes in the cylinder. That's a bad situation. You can also get wear in this seat arrangement where this ball sets, and this pressure is constantly going up through these little wire edges where this ball is supposed to be setting, which is pulling pressure out of the pump the whole time this is going on. Or this fit here, you can get wire here. This is a very tight clearance, millionths of an inch, or microns of a millimeter. So you can get wire here, and you get excessive return as well. Or there's a high pressure seal in the body of the injector. As you can see, this has a slight taper to it. So there's a seal in the body of the injector when you push this in, and these seals, over time can blow, essentially. They just get eaten away from pressure. So you can have a loss of pressure situation there. So there's many different things. The pump always seems to get the blame, and seldom is the real cause of the issue. So in today's marketplace, due to the fact that nobody really knows how to test this stuff, a lot of people don't even know how the common rail system works. There's shops out there that are taking people's money and doing this repair work. They don't even know how the common rail system works. But the problem is the secondary problem to that is for you, the consumer. They're going to recommend that you put the entire system on there, and that's quite expensive. So the whole reason we're offering this video is to educate the consumer how the common rail system works, and also to introduce a tool that is designed to test all these components independently and give you a definitive answer of what you need to put on. There's no guesswork with Common Rail EZ test. So typically the way these systems operate, and on the Cummins it's pretty easy to get to on a Cummins platform. All these returns tie together and they go into a common line that returns this return fuel back to the fuel tank. Well, with the Common Rail EZ test, we can also do this on the Duramax. It's a little more difficult to get to everything. But we can separate all these returns and measure these returns independently. We can break down to the point that we're independently measuring the return off of each injector by eliminating the others. So it's a really good way to find out exactly what your problem is. And we also offer some tests that no one has even thought of in the marketplace yet to do some further testing on these trucks. Let's say that you don't even think you've got a problem with yours. It starts good. Sometimes maybe it sounds a little bit odd, got a lot of miles on it. But there's tests in this Common Rail EZ that really are more suited to a test bench type setup. But we've incorporated these tests and made them to where they work really well on this interface. So what is the Common Rail EZ test? The Common Rail EZ test is a graphical user interface. It is a Windows application that will work on both a desktop, which is this, or it'll work on a laptop, which is this. It'll work on systems all the way from Windows XP through Windows 10. That includes Vista, 7, 8, 8.1, and 10. So very versatile, includes this controller module, and it connects through USB. This one's connected through this monitor. It has a USB path back to the PC. We connect to a flow meter, make positive and negative connections to the battery. We connect to the MPROP, fuel control actuator, fuel pressure regulator, whatever you want to call it. Connect up to the rail pressure sensor. This takes full control over the system, and the beauty of the system is this accurate flow meter that we use. We can measure, like I said, return off the fuel injectors. We can measure maximum pressure. We use MPa here, which times 10 would give you bar. This maximum for this test is 180 resolution of the sensor, which would be 1800 bar. That's for the, I don't even think we've got one set up in there, but that would be typical for your LB7 and your Cummins 5.9 LLY applications. But we separate all the returns independently through this T assembly. And what we'll do, primarily on the Cummins application, which same thing for all of them, this will be your injector return. We separate it from the other returns. We tie this into the CP3 as a return, but this is supposed to go into the flow meter first here. So we go through from the injector return into the flow meter. We go out of the flow meter into this T here, and we run one back to the tank out of the T, and the second one we run to the CP3 pump. So the only thing that's not here, that is not separated from the system, is the rail pressure relief valve. And we will verify maximum operating pressure as long as we're testing below the opening point of the rail pressure relief valve, even though it's tied back into the injector return. As long as it's not opening, it's not going to contribute anything to it. You can also get a plug. You can plug those off. You get those plugs online for $10 to $20 now, it seems like. But you can use one of those to make sure that it's not contributing anything more. And some of the rail pressure relief valves, they won't make enough pressure to run these tests. So, they give you the opportunity as a shop to upsell, sell someone a rail pressure relief valve, because higher pressure is higher efficiency, better fuel mileage, better fuel economy, more power. It's all those things. So we can go through, and there's several different tests we can run. We can do a pressure build test, which tests the system, tells us how long it takes to build pressure from cranking the engine to start up to maximum pressure. We look for a minimum number there. We can also do a leak rate test. We can test the leak rate, how long each injector holds pressure. We can separate those. We can test all those independently to find the condition of each injector, to see if it's a connector tube leaking or if it's wire internal to the injector. Whatever it is, we can determine what that is through that. We also have the injector return test, and we have specifications loaded into the testing interface. And it'll give you a percentage of, based upon what our flow specification is, it will give you a percentage rate from 0 to 100%. At 75%, it starts getting into the caution level. So, you don't want to test a truck and it be 95% of what the flow tolerance is, and the guy thinks it's okay. You want to be able to offer him recommendations of where to go from there. Third down here, we have or fourth actually, we have the injection start point test. It's labeled here as the injection start test. Critical test for idle quality, for smoke at idle, things of that nature. This test will, you may pass everything else and end up failing on this test. No one else even offers a test like this. We've incorporated this based upon our injector remanufacturing, and what we see on the actual test benches. We've incorporated one of those tests into on the vehicle test, and it's really a good test to run, because like I said, you may pass everywhere else and find you've got a problem here. Doesn't mean you need to replace all the injectors, but there is a service that can be done to the injectors to correct that. We have a CP3 return test. We can actually, find the condition of the CP3 as far as wear and durability. And we also have a CP3 cranking flow test. You've got a truck that won't start. We can run this test and see what's going on. This is called the Common Rail EZ test. So it is easy to test all these systems and figure out what's going on. We do have other test equipment available above and beyond this as well, but this is a great tool that every shop needs to really find out what's going on. You cannot combine all these return volumes together and measure one volume. I see people doing it all the time. They say, oh, it's over specification, we got to put the whole system on it. Well, you could have a relief valve that's contributing all this fuel into the return. You could have just one injector bad. You could have a high pressure connector leaking. You can have a blown high pressure seal in an injector. You cannot condemn an entire system based simply on reading the entire volume coming out of one return line with all of them combined together. That's crazy. That's like you having a water leak in your home, and the plumber comes to your house and he says, you got to replace your entire plumbing system. You wouldn't go for that. Why are you allowing people to tell you this according to your truck? You got one problem potentially. Now you may have to put an entire system on if it's full of rust or they're all bad, but if it's not bad, don't be telling people the stuff's bad. We'll be including some more videos which shows these tests in process. And we've got some trucks. We've got one that we're going to test, and we've already tested it once, and we do have some issues with it. It passed all the tests but one. We're going to pull the fuel injectors out. We're going to show you the tests first. We're going to go ahead and run them all again, video of that. But we're going to pull the injectors. We're going to put them on our test bench. We're going to run them. And hopefully the results are going to match up to what we're finding on our interface here, on our EZ test. And then we're going to recalibrate the injectors, put them back in the truck, rerun the test. So we're going to show you before and after. And, this is foolproof. This will show you, the truth of the testing versus what the test bench is showing you versus the truck afterwards. It'd be undisputable, what the proof and the truth is this way. So this is the way we do things here at Inventa Research and Development. Only the best for the customer and for the shops. We want everyone to know how these systems work and we want the consumer to realize that you don't have to put the whole system on there. We want the shop to realize, hey, it's not magic. It's not a system that we can't understand, that somebody's willing to show us how these things work and help us test them properly. We want to thank you for watching, and we hope that you'll tune in for our other videos, which will be coming up soon. Once again, this is Inventa Research and Development. We thank you for watching.